Hello student, today we will discuss a numerical question based on conservation of energy. Example number 6.8. To simulate car accident, auto manufacturer study the collision of moving cars with mounted spring of different spring constants. Consider a typical situation with a car of mass 1000 kg moving with a speed of 18 km per hour on a smooth road and colliding with a horizontally mounted spring of spring constant 6.25 10 to the power 3 Newton per meter. What is the compression of the spring? Maximum compression of the spring. This we have to discuss. So this is our spring, you can say, and spring is mounted here like this. This is the floor and the car is moving here. The speed of car is given, it is 18 km per hour. So when car is moving, it collides the spring, it will hit the spring and spring will get compressed. So here the conservation of energy will take place. When the car will strike here, the final kinetic energy will be zero because velocity is zero. So the kinetic energy, but the spring gets compressed. Suppose spring compressed by X. So from conservation of energy, Ke equal to stored energy in spring. Stored energy in spring. And the stored energy in spring will be half of kx square, that is why 1/2 mv square equal to 1/2 kx square. So this 2 will cut and we will get mv square equal to kx square, and we have to calculate the maximum compression. So the maximum compression will be given by x equal to mv square by k. Mass of the car is given root of this. So it will become root of m by k into v. Here the velocity of the car is given 18 km per hour. So 18 km per hour we can convert into meter per second, and that will become 18 into 5 by 18, hence it will be 5 meter per second. So when we put the value of mass and velocity and spring constant, we will get x. Mass will be 1000, spring constant 6.25 10 to the power 3, and outside 5 meter per second the velocity. So when we solve this, we will get x equal to 2.00 meter. Now in this question, what we have considered, there is no friction. Now suppose if the friction is there. Now suppose the car is moving and the coefficient of friction between the road is something. So then what will be the compression? This time the answer is 2 meter. Now if the same question and the same question in this way, the car is moving, this is our car and car is moving, but here the spring is there, the same spring having same spring constant 6.25 10 to the power 3 Newton per meter, but there is a friction and coefficient of friction is 0.5. So will we get the same compression? It is an example number of 6.9. So will we get the same compression? The car is moving with velocity 18 km per hour and the mass of car also given 1000 kg. So in this case, when car will move and car will go and it will strike the spring. So when it will hit the spring, see, the spring will be like this. Suppose the spring gets compressed by x and velocity of the car will 0. So in this time, the delta K, change in kinetic energy, delta K will be Kf minus Ki. It is equal to, Kf is final kinetic energy and final kinetic energy is 0 minus half of mv square. So, but the work done by net force, what will be the work done by net force? Work done by net force in this case, work done by net force, one work done, that is work done against spring force 1 by 2 kx square minus work done against friction, means minus means opposite friction, minus or plus, we can say the work done due to friction. So what will be the work done due to friction? So this will be this is, car is moving, so kinetic energy 1 by 2 mv square. Spring gets compressed to half of kx square minus and restoring force plus the friction force is here. So because of that friction force, work done 1 by 2 kx square kxm square plus minus friction force into x m. Why minus? Because it is opposite direction. But what will be the friction force? The frictional force will be, we know that friction force is F equal to mu n. This is friction force. So here friction force, N is normal reaction, so mu mg. The friction force will be mu mg because N equal to mg. So normal reaction, when block is kept, so mg will be here and normal reaction is here. So this normal reaction will be balanced. Friction force F equal to mu n, and we will write mu mg. So this we will write here for this friction. Hence the work done will be minus kxm square minus this plus minus minus f. F is what? Mu mg into xm. This will be the equation number 2. And this was the equation number 1. Now, according to conservation of energy, the energy before collision must be equal to energy after collision. So equating equation 1 and 2, because energy will be same. So when we equate equation 1 with equation 2, we will get minus half of mv square. This is equal to what? This is equal to minus half kxm square minus mu mgx, and we have to calculate this xm. When friction is not there, then this term will be 0, but since we have friction, therefore the work done against friction we have to consider. So when we solve, it will become 2 will go there, minus will cut. So in one step we will cut minus, and this minus is cut, so it will become mu g mg xm. Xm means maximum compression. Then this 2 will go, so mv square kxm square plus 2 mu mg xm. Then we have to calculate xm, so we can write kxm square plus 2 mu mg xm minus mv square equal to 0, and we will say that this equation is equation 3. Now if we have to calculate xm, so divide by k. Xm square plus 2 mu mg by k xm minus m by k v square. Then this will become a quadratic equation. You know quadratic equation, ax square plus bx plus c equal to 0. And to determine the value of x, we have this formula minus b plus minus under root of b square minus 4ac upon 2a. So the same thing we will use here. Yeah, we can use same thing here, and it will be, so our b will be what? Because it is the quadratic equation in xm, so a will be 1, no problem. Then we have b. This, apart from xm, everything will be b. So our b will be 2 mu mg by k. Our c plus c, so c will be minus whole mv square by k. Now we will put all these two values in this equation. So when we put here, what we will get? Let us see. When we put here, so then we will get we have to put here in quadratic equation. So b we will write this, and c we will write this. So let us see. B will be x equal to b will be minus 2 mu mg by k plus minus b square. So it's a square root of 2 mu mg by k the whole square minus 4, a is 1 and c is mv square minus mv square by k. C is minus mv square by k. In previously also you write c, we have written mv square by k, but it is minus mv square by k upon 2a. 2a is 1. Now we have to solve this. Then what it will be? It will become minus 2, this term we will write as it is, minus 2 mu mg by k plus minus this will become 4 mu square m square g square by k square plus minus minus plus 4 mv square by k. Now upon 2a, then you can put the value of k, mu, m in everything, so you will get xn. But before putting the value, we can simplify it. So it will become, see here, minus 2, and here we have mu mg by k. So what we can do here, we can take 2 common here, and in this equation k square. So here what we can do, you can multiply it with k. So it will become k square common, k square and 4, and remaining we cannot take common. So we can take 4 means root, first of all we'll take common here 4 and denominator k square, and then inside the bracket it will remain mu square m square g square, plus here it will remain only mv square k, and then upon 2a. So 2, then this 4 by k, out of the sign of the root, minus 2 mu mg by k plus 2 by k, and then we can write root of mu square m square g square plus mv square k by 2. This also we can write like this. So now we have this. So अब इन दोनों में से भी 2 by k is common. So minus 2 by k is common. Minus only 2 by k. 2 by k is common. Denominator, this 2 will be there. It will become mu mg plus root of this mu square m square g square plus mv square k. This is v square. Then this 2 cut, this 2 and this 2 will cut. So finally we will get minus mu mg k by k, and this finally we will get minus mu mg plus minus. If you take plus sign only, don't take the minus sign. You can take, so in minus, so it will be totally minus. So it will mu square m square g square plus mkv square upon k. Now here we will put minus, mu is 0.5, k is, m is 1000, g you can take 10 plus mu square 0.5 the whole square, m 1000 the whole square, g square means 10 the whole square plus m again only 1000, k 6.25 10 to the power 3, and v the 5 meter per second, because the speed was 18 kilometer per hour. And in denominator also we will write k 6.25 10 to the power 3 Newton meter square, and then we will solve. So solve this. This solution is not that easy, but it will only, this will become what, 110 will come here, it will become 5000 minus plus minus root of, this will become 0.25 into 10 to the power 1 2 3, 1 2 here, 3 3 6 6 and 2 8, 10 to the power 8, then plus this is 3 3 3 6, so 6.25 336 10 to the power 6 into 25. You can write here 25 divided by 6.25, 10 to the power 3. So this is 0.25, so it will become 10 to the power 6, and 10 to the power 6 and 10 to the power 6, so it will be outside. So minus 5000 plus minus 10 to the power 3, and it will become the 25 into 6.25, 10 to 20 into 25 divided by, this is 6.25, 10 to the power 3. Again you can solve that. 10 to the power 3, 10 to the power 3 common, so minus sign, minus, we can take here 10 to the power 3 common, and then it will become minus 5 plus 25, and this 25 we can take common, so 5 will be here. It will be 1 plus 6.25, bracket close. It will become 6.25, 10 to the power 3. This 10 to the power 3 will cut, so it will be minus 5 plus 5, 7.25 divided by 6.25. When you solve this, you will get 1.35 meter. So in this case, the xm will be this. This is the xm which is less than the xm which we got without friction. In this question has two part. See, if you see the right from the beginning, first we discussed this key car is moving and it is colliding, so with the car 5 meter per second, and the result was 2 meter. But when we consider the friction, then the equation was like this: kinetic energy, and this kinetic energy will be equal to the work done. Then the quadratic equation forms, and finally the result came, which was 1.35. This 1.35 and this was 2.00. So when we consider friction, the work done will be the compression in the spring is 0. This is a typical standard method to check the brakes in automobile industry. Thank you.